Welcome to Ask and Learn.
23.52, we have this hollow sphere with a thickness, internal radius internal radius A, external radius B. We're told its charge density, and we just want to find out what the magnitude of the electric field is at a number of points. So let's get started. Now, at r equals 0, a over 2, and a, we're within this region inside of a spherical shell of charge that's spherically symmetric. So we already know from discussion of Gauss's law that this means the field is 0 for all three of these. So we're 60% of the way there just based on remembering that fact. Now, in between A and B, life gets a little more interesting. There, the enclosed charge is going to be equal to the charge density times the volume that's enclosed. So the volume of our Gaussian surface will be 4/3 pi r, our coordinate, cubed, and we just subtract out the missing volume here, which is 4/3 pi a cubed. If I could draw a 4 that is legible. There we go. And of course we can factor out the 4/3 pi. 4 pi rho over 3 times the difference in radii cubed. And so the electric field is going to be one over 4 pi epsilon naught Q enclosed over r squared. This is just from Gauss's law, where this the electric flux is equal to Q enclosed over epsilon naught. 4 pi r squared is the surface area, and I've just rearranged this to find the electric field since that's what we're interested in. And so this works out to be just plugging this in for Q enclosed, rho over 3 epsilon naught, 3 epsilon naught, our differences in radii cubed, differences of the cubes of the radii rather. This may be a less confusing way of phrasing that, divided by r squared. And so if we put in 1.5a for r, we just evaluate that and we get 7.32 newtons per coulomb. Start up a new page here. So at r equals b, we're on the outer edge or outer surface of our shell. So we can still use the formula we were just using. The rho over 3 epsilon naught r cubed minus a cubed over r squared. Putting in b for r, which is 2 times a, we get 12.1 newtons per coulomb. And now, well, if we're outside of the whole thing now, so r greater than or equal to b, then it just looks like a point charge. Pi epsilon naught r squared. Or okay, the total charge. The total charge works out to be rho over 3. This epsilon naught is not part of the charge, but it goes there to look nice. And then b cubed minus a cubed. So rho over 3 times this difference is the total, well, plus a 4 pi, but then it cancels out there, over r squared. And so then 3 times b or 6 times a, whatever you like for r, or put in the actual numbers even, we find that our electric field has a magnitude of 1.35 newtons per coulomb here at 3 times the outer radius of the sphere.